Hello everyone, I'm Dr. Tokkummaa getahun, and today I'm here to explain some selected topics from different Oromia regions, and this lesson preparation was organized and sponsored by Oromia Education Bureau, and among the topics selected from different areas, one is organic compounds. Okay, the second most important class of organic compounds is oxygen containing compounds of hydrocarbons. They are also named as oxygenated hydrocarbons. So these are 6 in numbers. Okay, the first one is alcohols. Alcohols can also be named as alkanols. Alkanols. So OL indicates the presence of OH functional group because the functional group of alcohols is OH, and it is named as hydroxyl group. And the general formula for alcohol is ROH. In this case, R can never be hydrogen atom. If R is hydrogen, it becomes H2O, and H2O is water. Water is not an alcohol. Therefore, R must be alkyl group or aryl group. So this is the general formula for alcohol. The second one is ethers. Ethers are also oxygen containing compounds of hydrocarbons, and the ethers can be named as alkoxyalkane. Alkoxyalkane is the IUPAC name for ethers. Ethers can be named as alkoxyalkane. I will tell you this one later. And the general formula for ether is ROR prime. Oxygen is bonded with 2 alkyl groups. These alkyl groups may be the same or may be different. So we can name these kind of organic compounds, oxygen containing compounds of hydrocarbons, as ethers or alkoxyalkane. The third one is aldehydes. Aldehydes are also oxygen containing compounds of hydrocarbons. They are named as alkanals. Alkanal, AL, okay? This one indicates the presence of carbon to oxygen double bond directly bonded to hydrogen atom. And the general formula for aldehydes is RC double bond OH. This is carbon to oxygen double bond is carbonyl group. And the carbonyl group is the functional group for aldehydes or alkanals. And this can also be written as RCHO, okay? The fourth one is ketones. Ketones are also named as alkanons. Alkanon, O-N-E, okay? This one also indicates the presence of carbon to oxygen double bond directly bonded with alkyl groups or aryl groups. Therefore, they can be named as alkanons. The general formula for alkanons is R-C double bond O R prime. R and R prime may be the same or they may be different. But in this case, R prime can never be hydrogen atom. R also can never be hydrogen atom. If R is hydrogen atom, it becomes the general formula for aldehydes. But aldehydes are completely different from alkanons or ketones. And the fifth one is carboxylic acids. Carboxylic acids. Carboxylic acids are also known as organic acids. So you can also call them as organic acids. And their IUPAC names can be named as alkanoic acids. Alkanoic acids, okay? The general formula for this type of organic compounds is RC double bond OH. This C double bond OH is a functional group for carboxylic acids. And the name of this functional group is carboxyl group. Carboxylic group containing compounds are named as carboxylic acids or alkanoic acids, or they are also named as organic acids. And this is the general formula for carboxylic acid. You can also write as RCOOH or RCO2H because we have 2 atoms of oxygen in this molecule. Therefore, it can also be written as RCO2H. The sixth one is esters. Esters are also oxygen containing compounds of hydrocarbons. And the general formula for ester is almost similar with that of carboxylic acid, but here we have R prime, okay, but here it is hydrogen. Therefore, R prime can never be hydrogen atom. But R may be hydrogen atom or alkyl group or aryl group, or you can also say phenyl group, okay. So this is the general formula for ester. You can also write as RCOO R prime or RCO2 R prime. Okay, esters can be named as alkyl alkanoates. Alkyl alkanoates are the IUPAC names for esters. All these are oxygen containing compounds of hydrocarbons. Okay, let me show you the definition as well as some classification of these type of organic compounds. Important organic compounds. They are oxygen containing compounds of hydrocarbons, okay. So we have oxygen atom in addition to carbon and hydrogen atoms, because hydrocarbons are organic compounds containing only carbon and hydrogen atoms. But in this case, additionally, we have oxygen atoms in their molecule. These are 6 in numbers. They are also known as oxygenated hydrocarbons, or you can also call them as derivatives of hydrocarbons. Include alcohols, ethers, aldehydes, ketones, carboxylic acid, and esters. They are 6 in numbers. I already told you about this one. So let us see one by one. Especially, I will focus on their names, IUPAC names. Other one, for example, common name, their preparation, not only this one, all hydrocarbons, including alkanes, alkenes, etc. You can also see the preparation, their physical property, their chemical property, as well as their uses from your textbook. So alcohols, they are also named as alkanols. The functional group for alcohol is OH, and this functional group can be named as hydroxyl group. These are some examples of alcohols. This one contains OH, therefore this is a functional group for this molecule. And I told you that functional group is a part of molecule that determines the physical and the chemical property of that molecule. Therefore, because of the presence of OH in this molecule, this organic compound is classified as alcohol. And this one is also alcohol. But the difference between these two organic compounds is that here we have only methyl group, but here we have ethyl group. This one contains 2 carbon atoms, but this one contains only 1 carbon atom. And the name of this compound is methanol, but this one is ethanol, and this one is 1-propanol. Why 1-propanol? Because your OH functional group is on carbon number 1. If your OH functional group is on carbon number 2, the IUPAC name for that compound is 2-propanol. Okay, so I'll tell you this one later. So these are some examples of alcohols: methanol, ethanol, 1-propanol, or you can also name as propane 1-ol. This one indicates the position of OH group in this molecule. OL indicates the presence of OH functional group. That is a functional group of alcohol. Therefore, these are examples of alcohols. The general formula for alcohol, ROH2. This is for monohydric alcohol, okay? So we can classify alcohols based on their OH functional groups as monohydric, dihydric, trihydric, polyhydric, okay? I'll tell you this one later. So ethanol is the only alcohol present in all alcoholic beverages. Okay, classification of alcohols. Alcohol can be classified as monohydric. These are alcohols containing only 1 OH group in their molecule. Therefore, these are named as monohydric. Mono means 1. So, if you have only 1 OH group in the molecule, that alcohol can be classified as monohydric alcohol. For example, look at this organic compound. Look at this alcohol. We have only 1 OH group, but we have 2 carbon atoms. So, the name of this alkyl group is ethyl. Okay, I told you this one before. Therefore, the name of this compound is ethanol. It has only 1 OH group in the molecule. Therefore, this is monohydric. Why monohydric? Because we have only 1 OH group in the molecule. In this organic compound, we have also only 1 OH group. Therefore, this is also monohydric alcohol. The name of this one is ethanol. I told you about this one. This one, 1-propanol or propane 1-ol is the IUPAC name for this compound. So monohydric alcohols can also be classified into primary alcohol, secondary alcohol, and tertiary alcohol based on carbonyl carbon. What is carbonyl carbon? Carbonyl carbon is nothing but the carbon directly bonded to the OH group, to the functional group. For example, this carbon is carbonyl carbon. Okay? This carbon is carbonyl carbon. Why? Because it is directly bonded to the OH functional group. However, this one is not carbonyl carbon because it is not directly bonded to this OH group. It is bonded with this carbon and it is bonded with the 3 hydrogen atoms shown in this molecule. In this organic compound, this carbon is carbonyl carbon. The carbon directly bonded to the OH group. Therefore, based on this carbonyl carbon, we can also classify monohydric alcohols as primary alcohol. Primary alcohol, when carbonyl carbon is bonded with only one alkyl group, such type of alcohols can be named as primary alcohols. So the general structure for primary alcohol is this one. This is carbonyl carbon because it is directly bonded to the OH group, and this carbon is primary carbon. Therefore, an alcohol in which OH group is bonded to the primary carbon is simply known as primary alcohol. This carbon is only bonded with one alkyl group. Therefore, this carbon is primary carbon. It has 2 hydrogen atoms, okay? All the time remember this one. So, this is the general structure for primary alcohol. The carbon is primary carbon and the OH is directly bonded to that carbon. Because of that reason, we can classify this type of monohydric alcohol. Why monohydric? Because we have only one OH group in the molecule. Therefore, this is primary alcohol. Look at this carbon. The carbon directly bonded to the OH group, only bonded with one carbon atom. Others are hydrogen atoms. Therefore, this is one example for primary alcohol. Ethyl alcohol is the common name for this alcohol, but its IUPAC name is ethanol. The IUPAC name for this alcohol is 1-propanol, and its common name is N-propyl alcohol. This also primary alcohol because the carbon directly bonded to the OH group, that carbon is carbonyl carbon. I told you about that. Is bonded only with one carbon atom. Others are hydrogen atoms. Therefore, you can easily identify whether a molecule is primary alcohol or secondary alcohol by looking at the carbonyl carbon. The carbon directly bonded to the OH functional group. So this is ethanol and this one is 1-propanol or N-propyl alcohol is a common name for this alcohol, but ethyl alcohol is the common name for this alcohol. Secondary alcohol. In this case, you can easily identify whether the molecule is or alcohol is secondary alcohol or primary alcohol or tertiary alcohol only by looking at the carbonyl carbon. If, for example, the carbonyl carbon bonded to 2 the same or different alkyl groups, and if that carbon directly bonded to the OH group, such type of alcohols are named as secondary alcohols. Primary alcohol, I told you about that. Now I'm talking about secondary alcohols. Okay, so in this case, the carbon directly bonded to the OH group is bonded with 2 other alkyl groups. Okay, 2 carbon atoms. Therefore, this carbon is secondary carbon. All the time remember this one: primary carbon, secondary carbon, tertiary carbon. And the hydrogen atoms in primary carbon are known as primary hydrogen atoms. And the hydrogen atoms on the secondary carbon are named as secondary hydrogen atoms. And the hydrogen atoms on tertiary carbon are named as tertiary hydrogen atoms. But this carbon is secondary carbon. Why? It is directly bonded with 2 alkyl groups. And this carbon is also named as carbonyl carbon. Why? Because it is directly bonded to the OH functional group. Therefore, this is the general structure for secondary alcohol. So try to look at the carbonyl carbon to identify whether the alcohol is primary, secondary, or tertiary. Look at this organic compound, this alcohol. This carbon is carbonyl carbon. The carbon directly bonded to the OH group. The same carbon is bonded with this methyl group and as well as this methyl group. So it is bonded with 2 carbon atoms. Because of this reason, this alcohol is secondary alcohol. It is not primary alcohol, secondary alcohol. OH is directly bonded to the secondary carbon atom. Therefore, it is secondary alcohol. Look at this organic compound. This carbon is carbonyl carbon. The carbon directly bonded to the OH group is also bonded to this carbon atom and this carbon atom, 2 carbon atoms. Therefore, this carbon atom is secondary carbon. So, if OH is directly bonded to the secondary carbon, that alcohol is classified as secondary alcohol. What's the name of this organic compound? 2-propanol. Okay, this is the longest continuous chain. Your OH is on second position. If you number from left to right, it is on second position. From right to left, it is also on the second position. Therefore, the name of this alcohol is 2-propanol. 2-propanol is the IUPAC name for this alcohol. Its common name is isopropyl alcohol because this part is isopropyl. It is an alkyl group. I already told you about alkyl group. So you can also check from your textbook. You can also read alkyl groups from different materials. So it is really very easy to understand alkyl groups. So this is 2-propanol. What's the name of this one? When you start numbering from left to right, OH is on the second position. But when you number from right to left, it is on third position. All the time, you have to start numbering from the end, closer to the carbon directly bonded to the OH functional group. Therefore, the correct numbering system is from left to right. And the IUPAC name for this compound is 2-butane. An alkane that contains 4 carbon atoms is butane. In the case of alcohol, when you write the IUPAC name for alcohols, E of an alkane can be replaced by OL because OL indicates the presence of OH functional group. Because of this one, the IUPAC name for this compound is 2-butanol. 2-butanol is the IUPAC name for this compound. So try to identify this type of organic compounds from other. So this is the second classification. The third one is tertiary alcohol. This is also really very simple. If carbonyl carbon is bonded to 3 different carbon atoms, therefore, this type of alcohols can be classified as tertiary alcohol, contain OH group attached to a tertiary carbon atom. This carbon is tertiary carbon atom because it is bonded with 3 different carbon atoms, different alkyl groups. Okay, so this organic compound, this alcohol is tertiary alcohol. The general structure for tertiary alcohol is this one. Okay, let me show you one example. For example, this is best example for tertiary alcohol. Why tertiary? Because carbonyl carbon, the carbon directly bonded to the OH group, is also bonded to 3 other carbon atoms. Okay, therefore this carbon is tertiary carbon. Due to this, okay, this organic compound can be classified as tertiary alcohol. And what's the name of this alcohol? Okay, so the longest continuous chain contains only 3 carbon atoms. Okay, so this is the longest continuous chain. And on the second carbon atom, we have OH group. On the same carbon, there is also another substituent. That is methyl group. Okay, side chain. That side chain is methyl. Okay, therefore, because of this one, when you number from left to right, OH is on second position. From right to left, it is on second position. So you can use either of the two. When you start from left to right, this is on second position, this also on second position. So 2-methyl, 2-propanol is the IUPAC name for this compound. 2-methyl, okay? Then your OH is on second carbon, 2. Then an alkane that contains 3 carbon atoms is propane. E of an alkane must be replaced by OL to name the IUPAC names for alcohols. Because of this reason, the IUPAC name for this compound is 2-methyl 2-propanol. Okay, so this is an example for tertiary alcohol. Okay, let me ask you one question. CH3, okay, sorry, CH3, CH2, then CH3, CH3, CH2, OH. Is this alcohol primary alcohol or secondary alcohol or tertiary alcohol? So look at this carbon. The carbon directly bonded to the OH functional group. So this carbon is bonded only with this carbon atom. Therefore, this is primary alcohol. Okay, you can easily identify whether it is primary or secondary by looking at the carbonyl carbon. The carbon directly bonded to the OH groups. Another classification of alcohol based on OH group is dihydric alcohol. This one contains 2 OH groups. They are also named as glycols and diols. Okay, this is best example for dihydric alcohol. We have 2 OH groups in the molecule, therefore it is dihydric. Di means 2. okay? 2OH containing alcohols can be named as dihydric alcohol. What's the name of this alcohol? Okay, in this case, all the time, remember that if you have 2 OH groups at the end, you must use diol as a suffix, okay? So the name of this compound is, we have 2 carbon atoms, therefore 2 carbon atom containing alkane is ethane. Then you must indicate the position of OH group on carbon number 1, and on carbon number 2 we have 2 OH groups, 1,2 diol. This is the IUPAC name for this dihydric alcohol, okay? So all the time remember, okay, how to write the IUPAC names for organic compounds. This is ethane 1,2 diol. This is the IUPAC name for this alcohol. Its common name is ethylene glycol. Ethylene indicates the presence of 2 carbon atoms in the molecule. Therefore, ethylene glycol is the common name for this alcohol. The third one is trihydric alcohol. Alcohol that contains 3 OH groups in their molecular structure. Therefore, the example for this type of organic compound is this one. What's the IUPAC name for this organic compound? We have how many carbon atoms? 3. 3 carbon atom containing alkane can be named as propane. Okay, propane is the IUPAC name for an alkane that contains 3 carbon atom, propane. And we have 3 OH groups. Because of these 3 OH groups, this alcohol can be classified as trihydric alcohol. Tri means 3, okay? 3 OH groups in their molecule. So we have OH group on carbon number 1, OH group on carbon number 2, OH group on carbon number 3. 1,2,3, then triol. Why triol? Because we have 3 OH groups in this molecule. Therefore, the IUPAC name for this alcohol is propane 1,2,3 triol. Glycerin or glycerol is the common name for this alcohol. Another one is polyhydric alcohol. Alcohol containing 3 and more than 3 OH groups can be classified as polyhydric alcohols. Now you can write the IUPAC names for these organic compounds. We have OH on second position. So you must start numbering from right to left, because this carbon, the carbon directly bonded to the OH functional group, is closer when you start numbering from the right to the left. Therefore, the IUPAC name for this compound is 2,3 dimethyl 2-butanol is the IUPAC name for this organic compound. 2,3 dimethyl 2-butanol. In this case, we have OH on third position, okay? But this is hydrogen, 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 hydrogen. These are not side chains. There are no substituents. Hydrogen atoms cannot be considered as substituents or side chains. Only look at methyl group, ethyl group, bromo, fluoro, etc. Okay? But don't consider hydrogen as a side chain. So look at this methyl group. This methyl group is on second position if you start numbering from left to right. But if you start numbering from right to left, it is on the fourth position. But OH is on third position from left to right, and from right to left, it is also on third position. If the position of OH is equal from right to left and from left to right, so give priority for the substituents. For methyl, from left to right, it is on second position, but from right to left, it is on fourth position. So this is correct numbering to write the IUPAC name for this compound. So the IUPAC name for this compound is 2-methyl, then 3-pentanol. Why pentanol? Because totally we have 5 carbon atoms in the longest continuous chain. Therefore, an alkane that contains 5 carbon atoms in its molecule is pentane. E of an alkane can be replaced by OL to write the IUPAC name for alcohols. Due to this, the IUPAC name for this alcohol is 2-methyl 3-pentanol. 2-methyl 3-pentanol is the IUPAC name for this alcohol. Similarly, we have OH group on second position. We have no side chains, we have no substituents, so 2-hexanol, because the total number of carbon atoms in the longest continuous chain contains only 6 carbon atoms. Because of this one, an alkane that contains 6 carbon atoms is named as hexane. E of an alkane must be replaced by OL. Therefore, the IUPAC name for this compound is 2-hexanol. 2-hexanol is the IUPAC name for this compound. What about the IUPAC name for this compound? We have only OH on third position. We have no substituents. The total number of carbon atoms in the chain is 6. That is hexanol. So you must indicate the OH by Arabic numerals. Therefore, the IUPAC name for this compound is 3-hexanol. 3-hexanol is the IUPAC name for this alcohol. Okay, another example. This is bond line structural formula for alcohol. This vertex represents carbon atoms. I already told you about this one. The end line also indicates the presence of carbon atoms. So totally we have 1, 2, 3, 4, 5. 5 carbon atoms. We have no double bond. We have no triple bond. All the bonds are single bond. Therefore, so this OH is on carbon number 1 position. 1, 2, 3, 4, 5. Pentane, E of an alkane must be replaced by OL. Therefore, 1 pentanol is the IUPAC name for this compound. What about this one? We have 2 OH group. As the end, you must use the suffix diol to name the IUPAC name for this compound. But totally we have 3 carbon atoms. So propane, then 1, 3 on first position, and on third position we have OH groups. Therefore, propane 1,3 diol is the IUPAC name for this compound. What about for this one? We have double bond on the third position. So first write the IUPAC name for an alkene of this compound. Okay, remove this one first. So all the time you must start numbering from the end closer to the OH functional group. So you must start from this carbon atom. 1, 2, 3. On third position we have double bond. 3 butene. Okay, 3 butene because it contains 4 carbon atoms. 3 butene, 1 ol is the IUPAC name for this compound. So this is all about alcohols. You can read how to prepare alcohols and the physical properties, chemical properties, and the uses of important alcohols from different materials. Okay, the second important oxygen containing compound of hydrocarbon is ethers. They are also named as alkoxy alkanes. Oxygen is bonded to 2 alkyl substituents. In this case, we can call them as ethers or alkoxy alkanes. The general formula for ethers is ROR prime. R and R prime may be the same or they may be different. But in this case, R and R prime can never be hydrogen atoms. If, for example, R is hydrogen atom, this becomes the general formula for alcohol. If R prime is also hydrogen atom, it is the general formula for alcohol. It is not for that of ether. Because of this reason, R and R prime can never be hydrogen atoms. So this is the general formula for ethers. Okay, let us write the common names and the IUPAC names for ethers. In the case of common names, ethers can be named as alkyl followed by ether. Write the name of alkynes in alphabetical order. But if you have identical alkyl groups, therefore use the prefix di. So in this case, for example, di, then the name of this alkyl group is ethyl, diethyl ether, the common name for this ether. But in this case, this is ethyl, this is methyl. Ethyl comes first because of its alphabetical order. So ethyl methyl ether. But here diethyl ether is the common name for this ether, diethyl ether. Okay, the third example. Here we have ethyl group and this is isopropyl. Alphabetically ethyl must be written first, followed by this alkyl group isopropyl and followed by the name ether. So ethyl isopropyl ether is the common name for this ether, ethyl isopropyl ether. How can we write the IUPAC names for ethers? We can name them as alkoxy alkane. Okay, alkoxy is nothing but when oxygen is bonded to the methyl group or alkyl group, that group can be named as alkoxy group. Alkoxy. For example, this is methoxy. This part, including oxygen, it can be named as, for example, this one is named as isopropoxy. And this one is named as, for example, ethoxy. And this one is named as methoxy. Okay? But you must indicate this alkoxy group by number, by Arabic numeral. So the first one is selecting longest continuous chain. The second one is numbering system. This one is longest continuous chain, and you must start from this one, from left to right. Why? Because this group is nearest to this carbon atom. But when you start from right to left, it is far from the end carbon atom. Therefore, this is on second position. This one is carbon number 1, carbon number 3, carbon number 4. The name of this alkane is butane. And we have methoxy group on the second position. Therefore, the IUPAC name for this compound is 2-methoxybutane. Similarly, for example, we have ethoxy group on carbon number 1 position. This one is longest continuous chain. So you must select the longest continuous chain first. After that, numbering system. This one is closer to the ethoxy group. Therefore, numbering system starts from this carbon. Number 2, carbon number 3, carbon number 4, carbon number 5. This is pentane. On carbon number 1, we have ethoxy. Therefore, 1-ethoxy pentane is the IUPAC name for this ether. Therefore, the third one is aldehydes. Aldehydes can also be named as alkanals. The functional group of aldehydes is carbon to oxygen double bond directly bonded to the hydrogen atom. If C double bond O is bonded to the hydrogen atom, therefore that is the functional group for aldehydes. They are also named as alkanals. So this is the general formula for aldehydes. I already told you about this one. You can also write by using this detailed structure. So this is complete structure for the general formula of aldehydes. Okay, let us write the common names for some aldehydes. For example, formaldehyde. So you must use the common name of carboxylic acid to write the common name of aldehyde. For example, carboxylic acid that contains one carbon atom is named as formic acid. Formic acid is the common name of an acid, an organic acid, or a carboxylic acid that contains one carbon atom. So this name is derived from Latin word, okay, formica. Formica means ant. Therefore, this one, or formic acid, the structure for formic acid is HC double bond OH, or you can also write as HCOOH or HCO2H. So this is formic acid. It is derived from the Latin word formica, which means ant. So this is a chemical defense for ants, okay? So it is found in ants. That's why it is named as formic acid. Therefore, IC acid of the carboxylic acid must be replaced by aldehyde to name the common names of aldehydes. So formaldehyde. Formaldehyde is the common name for this aldehyde. Okay, this one contains 2 carbon atoms. And the carboxylic acid that contains 2 carbon atoms. For example, CH3, C double bond OH is acetic acid. Acetic acid is the common name for this carboxylic acid. Okay, it is derived from Latin word acetum, which means vinegar. It is found in vinegar. That's the reason it is named as acetic acid. So to write the common name for this aldehyde, IC acid must be replaced by aldehyde. Okay, IC acid must be replaced by aldehyde. So acetaldehyde. Acetaldehyde is the common name for this aldehyde. An aldehyde that contains 2 carbon atoms. So this is an aldehyde that contains 3 carbon atoms. And the carboxylic acid that contains 3 carbon atoms can be named as propionic acid. CH2, then C double bond OH. The name of this compound. The common name for this compound is propionic acid. Propionic acid. It is derived from Greek word propion, which means milk. So it is found in milk. Because of this reason, it can be named as propionic acid. This is the common name of an acid that contains 3 carbon atoms. So to name the common name of this aldehyde, IC acid of the carboxylic acid must be replaced by aldehyde. Therefore, the common name for this aldehyde is propionaldehyde. Okay, another one is the IUPAC names for aldehydes. In the case of IUPAC names, you must just select the longest continuous chain first. Then numbering system. Numbering system of aldehydes is really very easy because all the time carbon to oxygen double bond, by convention it must have C1. Okay, this is carbon number 1 to write the IUPAC name for this compound. But we have methyl group on 3rd position. Therefore, the name IUPAC name for this aldehyde is 3-methyl. We have how many carbon atoms in the longest continuous chain? 4 carbon atoms. Therefore, an alkane that contains 4 carbon atoms is butane. E of an alkane must be replaced by al, okay, to write the IUPAC name for aldehydes. Therefore, this is 3-methyl butanal. 3-methyl butanal. Okay, what about this one? We have ethyl group on the 2nd carbon atom. Alkane that contains 5 carbon atoms is simply known as pentane. E of an alkane must be replaced by al, alkanal. So pentanal. We have ethyl group on 2nd position, 2-ethyl pentanal. is the IUPAC name for this compound. 2-ethyl pentanal is the IUPAC name for this aldehyde. Another one is ketone. Ketones can also be named as alkanone, O-N-E. This one indicates the presence of carbon to oxygen double bond directly bonded to carbon atom, not with hydrogen atom. If, for example, bonded with hydrogen atom, that is an aldehyde. It is not a ketone. So this is the general formula for ketones, and you can also write in this detailed structure RC double bond O R prime. R and R prime may be the same or they may be different, but R and R prime can never be hydrogen atoms in this case. So this is the general formula for ketones or alkanones. How can we write the common names and IUPAC names for ketones? Okay, in the case of common names, this is almost similar with that of ether. First, name the alkyl groups directly bonded to the carbon to oxygen double bond. This is the functional group, and the name of this group is carbonyl group. Ketone contains carbonyl group. Aldehyde also contains carbonyl group. Both of them are known as carbonyl compounds. Therefore, name first alkyl group. If you have similar alkyl groups, use the prefix di. The common name of this ketone is dimethyl followed by ketone. Okay, dimethyl. First, name alkyl groups. If you have similar alkyl groups, use the prefix di. Therefore, we have two similar methyl groups, and the common name of this ketone is dimethyl ketone. It is also named as acetone. Acetone is the common name for this organic compound, dimethyl ketone or acetone. So how can we write the common name for this ketone? We have ethyl group and we have also methyl group. You must write in alphabetical order. Ethyl comes first, followed by methyl, then followed by the name ketone. Ethyl, methyl, ketone is the common name for this ketone or alkanone. In the case of IUPAC names, or to name the IUPAC name for this type of organic compounds, as the end you must use ONE as a suffix. For example, propane of an alkane, from this alkane, E of an alkane must be replaced by ONE, propanone, butanone, pentanone, hexanone. It continues just like that. But all the time indicate the position of carbon to oxygen double bond by number. So the IUPAC name for this compound is 2-pentanone. Okay, it is really very simple. 2-pentanone, or you can also write as pentane 2-ONE. This ONE indicates the presence of carbon to oxygen double bond, which is directly bonded to two alkyl groups. Therefore, the IUPAC name for this compound is 2-pentanone. What about the IUPAC name for this compound? We have carbon to oxygen double bond on third position, and the longest continuous chain contains 5 carbon atoms. An alkane that contains 5 carbon atoms is pentane. E of an alkane must be replaced by ONE. Therefore, the IUPAC name for this ketone is 3-pentanone. 3-pentanone is the IUPAC name for this ketone, or pentane 3-ONE. Another one is carboxylic acids. They are also named as alkanoic acids, and they are also known as organic acids. I told you about this one. And the general formula for carboxylic acids is RC double bond O OH, or you can also rewrite as RCOH, RCO2H, because we have 2 oxygen atoms. Or this is detailed structure or detailed general formula for carboxylic acid, RC double bond OH. We have carbon to oxygen double bond, and we have also OH group as a functional group of this molecule, and this functional group is named as carboxyl group. Carboxyl group is the functional group for carboxylic acid. So this is the general formula for carboxylic acid. R is either hydrogen or an alkyl group for aliphatic, but for aromatic, R is phenyl group or aryl group. If, for example, you have benzene ring and you have COH group, carboxylic group directly bonded to the benzene ring, that one is aromatic carboxylic acid. But if R is alkyl group or hydrogen atom, these type of carboxylic acids are named as aliphatic carboxylic acid. So try to differentiate between aliphatic carboxylic acids and aromatic carboxylic acid. If COH is directly bonded to the benzene ring, that one is aromatic carboxylic acid. If COH group is bonded to alkyl group or hydrogen atom, so that carboxylic acid is aliphatic carboxylic acid. So these are some saturated monocarboxylic acid. Saturated monocarboxylic acid. Saturated means if you have only single bonds between carbon atoms, not this one, okay? Don't see this double bond between carbon and oxygen atoms. This is a functional group of this organic compound with OH. This part is carboxyl group, and that is a functional group of carboxylic acid. The name of this one is, its common name is formic acid. I already told you about that one. Its IUPAC name is methanoic acid. Methanoic, methane. E of an alkane must be replaced by oic acid to write the IUPAC name for carboxylic acid. Okay, carboxylic acids containing, for example, 2 carbon atoms. This one, we have 2 carbon atoms, okay? So, alkane that contains 2 carbon atoms is simply known as ethane. E of an alkane must be replaced by oic acid to write the IUPAC name for this carboxylic acid. Therefore, it is ethanoic acid. Ethanoic acid is the IUPAC name for this organic acid. Its common name is acetic acid. I told you about that. So it is derived from the Latin word acetum, which means vinegar. So this is present in vinegar, okay? That's why it is named as acetic acid. The common name for this one is propionic acid. It is derived from the Greek word propion, which means milk, okay? Therefore, propionic acid is the common name for this carboxylic acid. Its IUPAC name is propanoic acid. Propane, E of an alkane must be replaced by oic acid to write the IUPAC name for this carboxylic acid. Simplest aromatic carboxylic acid is benzoic acid. Benzoic acid is the common name for this simplest aromatic carboxylic acid. Its IUPAC name is benzene carboxylic acid. So don't be confused here. The IUPAC name of this organic compound is benzene carboxylic acid. If, for example, you have substituent on the 4th position, the IUPAC name for this compound is 4-methyl, for example. If you have methyl group on 4th position, 4-methyl benzene carboxylic acid is the IUPAC name for this compound. The common name for this compound is paramethyl benzoic acid. Okay, benzoic acid is the common name for this simplest aromatic carboxylic acid. Its IUPAC name is benzene carboxylic acid. Di and tricarboxylic acid. Carboxylic acids that contains 2 COH group in their molecule, they can be named as dicarboxylic acid. If you have 3 COH group, 3 carboxyl group in the molecule of say type of organic compounds, therefore that carboxylic acid is simply known as tricarboxylic acid. 2 carboxyl group dicarboxylic acid and 3 carboxyl group tricarboxylic acid. For example, look at this organic compound. We have C double bond OOH, 1 carboxyl group on the left, and C double bond OH, another carboxyl group on the right. Therefore, we have 2 carboxyl group in this molecule. Because of this one, this is classified as dicarboxylic acid. What's the name of this dicarboxylic acid? In naming IUPAC name for such type of organic compounds, all the time you must use dioic acid as a suffix. Okay, 2 carbon atom, ethane, then ethane dioic acid, propane dioic acid, butane dioic acid, pentane dioic acid. It continues just like that. But the common name for this dicarboxylic acid is oxalic acid. Oxalic acid is the common name for this dicarboxylic acid. Its IUPAC name is ethane dioic acid. Okay, another example. Okay, look at this organic compound. You have how many carboxyl groups? 2 carboxyl groups. And the total number of carbon atoms in this molecule is 3. And an alkane that contains 3 carbon atoms is propane. So propane dioic acid is the IUPAC name for this dicarboxylic acid. Okay, another example. You have also 2 carboxyl functional groups in this molecule. And the total number of carbon atoms are 4. Therefore, an alkane that contains 4 carbon atoms is butane. Therefore, as the in, you must add dioic acid as a suffix. Therefore, the IUPAC name for this compound is butane dioic acid. Its common name is succinic acid. The common name of this propane dioic acid is malonic acid. Okay, this one oxalic acid, malonic acid, succinic acid. For example, if you have 5 carbon atoms, glutaric acid. So this is butane dioic acid. This is the IUPAC name for this dicarboxylic acid. Another one, aromatic dicarboxylic acid. For example, you have two COH groups. Both of them are directly bonded to the benzene ring. Therefore, the IUPAC name for this one is 1,2 benzene dicarboxylic acid. This is the IUPAC name for this compound. So we have two COH functional group. You must indicate by number. These functional groups by number, 1,2 position. So 1,2 benzene dicarboxylic. Di. Why? Because we have two COH functional group. Its common name is phthalic acid. This is a common name of this aromatic dicarboxylic acid. 1,3 position. So it is similar with this one. The only difference between the two is just indicating the position of COH group by numbers. So this is 1,2 position, but in this case it is 1,3 position. Therefore it is 1,3 benzene dicarboxylic acid. Isophthalic acid is the common name for this aromatic dicarboxylic acid. Third one is this one, 1,4 position. It is similar with this one. 1,4 benzene dicarboxylic acid is the IUPAC name for this carboxylic acid, and the terephthalic acid is the common name for this aromatic dicarboxylic acid. So these are aromatic dicarboxylic acids. 3 carboxylic group, it is simply named as tricarboxylic acids. I already told you about this one. The best example for tricarboxylic acid is citric acid. In citric acid, we have 3 COH groups. So this is citric acid. COH, 3 COH group. Therefore, it is classified as tricarboxylic acid. How can we name the common names and IUPAC names for carboxylic acid? I already told you how to name the common names for straight chain, aliphatic, saturated carboxylic acid. So we have only one carbon atom. This is formic acid. It is a chemical difference for anthus. It is derived from the Latin word formica, which means ant. I already told you about this one. So formic acid is the common name for this carboxylic acid. Second example. The second example, we have 3 carbon atoms. Okay. Therefore, the common name for this carboxylic acid is propionic acid. Propionic acid. So it is derived from Greek word propion, which means milk. Therefore, it is named as propionic acid. Carboxylic acid that contains 2 carbon atoms. Acetic acid. It is derived from the Latin word acetum, which means vinegar. I already told you about that one. So this is propionic acid. Another example, okay, carboxylic acid that contains 5 carbon atoms in its molecule. 1, 2, 3, 4, 5. Its common name is valeric acid. It is found in valerian herbs. That's why it is named as valeric acid. Valeric acid is the common name for this acid. The acid that contains 5 carbon atoms. Okay, its IUPAC name is pentanoic acid. The IUPAC name for this compound is propanoic acid. The IUPAC name for this organic compound that contains 1 carbon atom is metanoic acid. So you can easily name, okay, their IUPAC name as well as their common name. The fourth example is this one. For example, if you have substituents, you must indicate by using Greek letters alpha, beta. Alpha is on the carbon directly bonded to the carboxyl group of that carboxylic acid. So this is alpha position, this one is beta position, then gamma position. It continues just like that. Therefore, the name of the substituent must be indicated by this Greek letter. So we have chloro on alpha position. Alpha, chloro, and the common name of carboxylic acid that contains 3 carbon atoms is propionic acid. Therefore, alpha chloro propionic acid is the common name for this carboxylic acid. Alpha chloropropionic acid. Okay, another example. Look at this organic compound. So we have methyl group on alpha position. Alpha, beta, gamma, delta. This is only for common naming system for carboxylic acid. But in the case of IUPAC naming system, you must indicate the position of the substituents or side chains by using Arabic numerals. So we have methyl group on alpha position and another methyl group on gamma position. Therefore, alpha, gamma, dimethyl. How many carbon atoms? In the longest chain, we have 1, 2, 3, 4, 5. So the common name of carboxylic acid that contains 5 carbon atoms is valeric acid. Therefore, the common name of this organic acid is alpha, gamma, dimethyl valeric acid. Okay, so let us come to the IUPAC names for carboxylic acid. I already told you that if you have only 1 carbon atom, the IUPAC name for that carboxylic acid, metanoic acid. 3 carbon atoms, propanoic acid. 2 carbon atoms, ethanoic acid. 4 carbon atoms, butanoic acid. 5 carbon atoms, pentanoic acid, hexanoic acid. It continues just like that. So it is dependent on the IUPAC names of alkanes. E of an alkane must be replaced by oic acid, methanoic acid, methane. Then E must be replaced by oic acid. Methanoic acid is the IUPAC name for this organic acid. Propanoic acid. This one pentanoic acid. 2 carbon atoms, ethanoic acid. 4 butanoic acid. If we have substituents, how can we write the IUPAC names for those carboxylic acid? So we have methyl group 1, 2, 3 on third position. The structure for this compound is CH3, then CH. On CH we have CH3, okay, then CH2, then C double bond O, OH. This must be carbon number 1 all the time. Then this is 2, this is 3, and this one is 4. We have methyl group on third position. Therefore, 3-methyl, an alkane that contains 4 carbon atoms is butane. E of an alkane must be replaced by oic acid. So 3-methyl butanoic acid is the IUPAC name for this compound. 3-methyl butanoic acid. Similarly, the IUPAC name for this compound, we have methyl group on second position and the chloro on third position. Chloro must come first. Why? Because of its alphabetical order. Therefore, 1, 2, 3, 3 chloro, 2 methyl, 1, 2, 3, 4, 5. 5, okay, pentanoic acid. Therefore, 3 chloro, 2 methyl, pentanoic acid is the IUPAC name for this compound. 3 chloro, 2 methyl, pentanoic acid. Another one, dicarboxylic acid. We have 2 carboxyl groups in this organic compound. So how can we name the IUPAC name for this compound? 1, 2, 3, 4. For butane, E of an alkane must be replaced by dioic acid. Why? Because of the presence of 2 COH groups in the molecule. Therefore, butane, dioic acid is the IUPAC name of this compound. Succinic acid is the common name for this organic compound. Succinic acid is a common name. Butane dioic acid is the IUPAC name for this compound. Okay, if you have, for example, substituents on the benzene ring on this type of organic compound, IUPAC name must be written as 2-bromo, then benzene carboxylic acid. What is the common name for this carboxylic acid? On ortho position we have bromine. Ortho-bromo benzoic acid is common name for this organic compound. So you can also write the IUPAC names for other carboxylic acid in a similar way. Okay, another one, or the last one, is esters. This is the last oxygen containing organic compounds or oxygen derivatives of hydrocarbons. The general formula for ester is RCO or R prime, RCO2 R prime, or RC double bond O R prime. This one is detailed general formula for esters. They can be named as alkyl alkanoids. So they are the most widely occurring compounds in nature, and many of them are pleasant smelling substances, and they are responsible for the flavor and the fragrances of many fruits, oils, fats, waxes of plants or animal origin. All of them are esters. So esters naturally available in fruits and responsible for their pleasant fragrances. Okay, some of them are, for example, isoamyl, isovalerate. This is found in apple. So you are familiar about apple. So this is apple. An ester that is found in an apple is isoamyl, isovalerate. This is the formula for isoamyl, isovalerate. Therefore, this ester is responsible for the good flavorance of this apple. And second one is ethyl butyrate. So the formula for ethyl butyrate is this one. It is found in pineapple. So this is pineapple, and it is responsible for the pleasant fragrance of this pineapple. The third one, isopentyl acetate. This is found in banana. This is a formula for isopentyl acetate. Therefore, this is responsible for the pleasant fragrances of banana. Another one is octyl acetate. This is an ester found in orange, and therefore it is responsible for the pleasant smell of this orange. Another one is an ester that is found in grapes is methyl anthranilate. This is the formula for that ester, And the last one is isopentyl acetate. This one is found in pear. So this is pear. We can also write the common names and IUPAC names of esters based on the common names and IUPAC names for carboxylic acid. So this is derived from an alcohol, and this part is derived from carboxylic acid. All the time, naming of an ester must start from the portion that comes from an alcohol. So this is methyl. This one is, for example, the common name of carboxylic acid that contains 2 carbon atoms is acetic acid. Methyl acetate is the common name for this organic compound. Methyl ethanoate. Methyl ethanoate is the IUPAC name for this compound, and then you can also see the names, common names as well as IUPAC names of these organic compounds. For example, this one is the portion that comes from an alcohol. It is named as ethyl. Then this one contains 2 carbon atoms, and this is derived from carboxylic acid. And the name of the carboxylic acid that contains 2 carbon atoms is acetic acid. The common name for this ester is ethyl acetate. Its IUPAC name is ethyl ethanoate. Ethyl ethanoate is the IUPAC name. Ethyl acetate is the common name. So look at the common names as well as IUPAC names for these organic compounds. So some of these questions are from university entrance exam questions. Let us answer together. The first question says the first organic compound was synthesized in the laboratory by what? By Frederick Euler. I already told you about this one. A is the answer for this question. Question number 2. The first organic compound that is artificially synthesized from inorganic starting material is what? Urea. Urea is the first organic compound synthesized in the laboratory by Frederick Euler from inorganic compound. What is that inorganic compound? Ammonium cyanide. The correct answer for this question is C. Urea is the first organic compound synthesized in the laboratory, and this is the structure for urea. Third question. Which of the following hydrocarbons does not belong to the homologous series of alkane? So you can use the general formula for alkane, CnH2n plus 2. All the time, if you remember this one, you can easily answer this question. For example, C3H8. If 3, then 3 times 2 is 6 plus 2, 8. C3H8, this is an alkane. C8H18, 8 times 2, 16 plus 2, 18. So this is also an alkane. C6H10, 6. C6, 2 times 6 is 12 plus 2, 14. It must be 14. But here it is H10. Therefore, this one does not belong to the homologous series of alkane. But the last one, C10. 10 times 2 is 20 plus 2, 22. So C10, H22 is decane. This also belongs to the homologous series of alkane. Fourth one, which of the following alkanes is liquid at room temperature? C1 to C4 are gases, C5 to C17. Okay, 5 to 17. They are liquid. So B is the correct answer. And the fifth question, the general formula that represents olefin, that means alkenes. It is CnH2n. So D is the correct answer. Sixth question, which of the following acid is used as chemical difference for anths? I already told you about this one. Formic acid. What is the molecular formula for formic acid? HCO2H. So HCOH, this is formic acid. B is the correct answer. This one is acetic acid. It is found in vinegar, acetum, but this is alcohol. This is not an acid. This one is also an alcohol. It is not an acid. Therefore, B is the correct answer for this question. Question number 7. Which of the following compounds is ether? This one COOR. RCOOR prime. This is an ester. RCOOH. This is carboxylic acid. Because we have carboxylic group. This is a functional group for carboxylic acid. CHO. This is an aldehyde. ROR prime. This is an ether. So D is the correct answer. Question number 8. The compounds methanol and this one is acetic acid or ethanoic acid react in the presence of an acid catalyst to form what? When alcohols react with carboxylic acid, all the time ester is formed. And this reaction is known as esterification reaction. So D is the correct answer. Chemically, all fats and oils are, I already told you about this one. So all of them are esters. So C is the correct answer. The correct IUPAC name for the following compound. Okay, so how can we write the IUPAC name for this compound? We have OH group, so this is an alcohol. All the time you must start numbering from this carbon atom. Okay, this is number 1, 2, 3, 4, 5, 6, 7, 8. Why? Because this is the longest continuous chain. Therefore, we have substituents on third position. That substituent is methyl, and another methyl on the same carbon atom, methyl. And also another methyl group on sixth position. Therefore, 3, 3, 6 trimethyl, then 2, 8 carbon atom. This is octanol. Therefore, C is the correct answer. Okay? Other options are not correct. Therefore, the correct answer for question number 10 is C. So, this is all about organic compounds. Thank you for watching and thank you for listening. See you next time. Until then, bye-bye.